First of all, we need to know what is volumetric analysis. Volumetric analysis is a quantitative method used to determine the concentration of a substance in a sample by reacting it with a solution of known concentration. Basically, the process involves adding a reagent slowly into the analyte until the endpoint is reached. This method is also known as stoichiometric analysis, where the volume of reagent used is measured to identify the concentration, purity, and composition of a substance. In a real-life application, volumetric analysis is commonly applied in the food industry to ensure the product safety as well as monitoring environmental health and supporting medical treatments. For this study, the method is used to determine the concentration of acetic acid in vinegar.
Hello everyone, today I'll be walking you through the chemical theory and calculations behind our experiment. As you can see in this slide, our core objective is to determine the exact concentration of acetic acid, which is a weak acid found in standard vinegar, by titrating it against a standardized strong base, sodium hydroxide. This is a classic acid-base neutralization reaction governed by the chemical equation as shown in the slide. Our ultimate goal in the lab is to reach the equivalence point, which occurs when the moles of acid exactly equal the moles of base acid. To visually capture this moment, we use a phenolphthalein indicator. The moment our solution permanently changes from colorless to a very faint light pink, we have hit our endpoint, signaling that the neutralization is complete.
Alright, so right now we are talking about methodology. So we have A, which is at-home experiment. At-home experiment means that you can easily do the experiment inside your house, or maybe the ingredients are easily found in the kitchen, or maybe in your house, or maybe you can buy it from the store, get it from the supermarket and whatsoever. Alright, so first of all, you need to prepare a red cabbage, which the red cabbage acts as a pH indicator. And then take some of the leaves, you cut it with like the knife, or maybe you tear it with your hands. And then secondly, number 2, you need to boil it in hot water for 2 minutes and let it cool down. And then third, you need to take out the leaves from the water that you boiled it in, and then add a cup of distilled water. You can also use tap water actually. And then fourth, you need to prepare 5 empty and clean glasses, and you need to label it each with lemon, vinegar, water, baking soda, and washing powder. Meaning that if you label the glass with lemon, you add lemon in the glass. And then fifth, you need to pour each of the substances into each glasses of red cabbage juice, just like I mentioned. If you label it with baking soda, just add baking soda into the glass. And then finally, number 6, you need to observe the reaction and the changes of color. Meaning that while you pour the substances into our indicator, you need to observe like the changes of color, like what color it changes into, and you need to refer to the pH like table to determine what pH it is. And yeah, that's all.
Okay, so today I will explain about the methodology of volumetric analysis. So the first thing was sodium hydroxide solution was filled into a burette. 1 ml of vinegar was measured and filled into a conical flask. Then distilled water and a few drops of phenolphthalein indicator were added to the vinegar sample. Sodium hydroxide solution was added from the burette to the flask while the flask was shaken gently. Titration was stopped when the solution is turned into the light pink and the color was remained for about 30 seconds. The volume of sodium hydroxide was recorded and the experiment was repeated 3 times to obtain the accurate results. The solution of acetic acid in the vinegar was calculated using the equation H3COOH plus NaOH equal to CH3COONA plus H2O.
Now let's transition to the calculation slide to see how we transform our data through a 5-step calculation. Step 1 is standardization. Before we analyze the vinegar, we have to find the exact molarity of our sodium hydroxide base using the standard acid hydrochloric data via the formula as shown in the slide. Step 2 is finding the moles of base. We take that freshly calculated molarity and multiply it by the average volume of sodium hydroxide used during our vinegar titrations. Step 3 is the bridge because our chemical equation shares a strict 1-to-1 stoichiometric ratio. The moles of acetic acid simply equal the moles of sodium hydroxide consumed. Finally, step 4 and 5, we convert those moles of acetic acid into grams by multiplying by its molar mass of 60.05 gram per mole. From there, we find the final weight by volume percent content by dividing that mass by our original vinegar sample volume and multiply by 100%.
Hello and good day everyone, I'm Raja and I will be presenting the example result section for this experiment. For the experiment to determine the concentration of acetic acid in vinegar, we conducted 3 titration trials to ensure accuracy and precision of our results. As shown in the data table, our titration volumes were consistent with an average volume of sodium hydroxide used being 24.08 milliliters. The endpoint of the titration was marked by a permanent color change from colorless to light pink using phenolphthalein as the indicator. The known data includes the standardized sodium hydroxide molarity of 0.0980 molar, a vinegar sample volume of 10 milliliters, and the stoichiometric ratio of this acid-base reaction, which is 1-to-1. Based on the calculation, the moles of sodium hydroxide that reacted were 0.0236 moles. Since the ratio is 1-to-1, the moles of acetic acid are also 0.0236 moles. After converting moles to mass using the molar mass of acetic acid, which is 16.05 grams per mole, and applying the dilution factor, we found the mass of acetic acid. We found the mass of acetic acid in the original sample to be 0.56. 5.68 grams. Therefore, the final result shows that the concentration of STSC in this vinegar sample is 5.67% weight per volume. This value falls within the commercial standard range of 4 to 8%, proving that this vinegar sample is safe and meets food quality standard. In conclusion, this experiment has successfully demonstrated the application of volumetric analysis in determining the concentration of FCTSC in a commercial vinegar sample. Our result of 5.67% weight per volume proves that the acid-base titration method is a simple, accurate, and cost-effective technique for quality control purposes in the food industry. Volumetric analysis plays a very important role in ensuring consumer safety. Besides the food industry, this technique is also widely used in the pharmaceutical industry to test drug purity, in environmental monitoring to measure water acidity, and in beverage production such as wines and fruit juice. Overall, volumetric analysis remains one of the fundamental techniques in analytical chemistry. It proves its relevance in our daily lives through practical application like ensuring the quality of the food we consume every day. That's all from me. Thank you.